Thank you very much. I love the introduction of moving from fishing to rugby. I'm South African and I've lived in New Zealand now for, 11, going on to 12 years, so rugby is definitely in my blood. And apologies for the Dutch people. We don't talk about to the Dutch much if we're South African, especially if you look at cricket, because I think you guys trumped South Africa, was it last week, in cricket, which wasn't great for South Africa, but good for the Dutch. And then you're right, yeah, Rugby World Cup up next year in France. And I spoke to Shay yesterday, and yeah, it could be anyone's World Cup, eh? Albeit that South Africa still holds that World Cup, eh? From the it won't be England or Australia. That's where my money is on. Thanks for the kind introduction, and yeah, hopefully I give you a little bit of a different perspective on the science that sits behind food safety, and very much a perspective from industry. So VENTER would maybe not be that familiar to many of you. We are New Zealand's largest company, and those of you that don't know where New Zealand is, it's on the other side of the planet. A very small island. We actually have two islands, a North Island and a South Island, and it's about 3.5 hours from Sydney in Australia by plane to get to New Zealand. It's a beautiful country. One of the intern students, Esther, is here as well, and she spent a bit of time there. It's absolutely a beautiful country, and I'd invite all of you to come and visit New Zealand now that it's open post-COVID. So VENTER is a dairy company. We're not the world's largest dairy company, but we still are one of the largest exporters in the world. So about a $20 billion company-ish. We manufacture a lot of milk. We're a cooperative, so we belong to about 10,000 farmers. They own us, which is a very nice model to work in. Yeah, and we've got about between 4 and 5 million cows in New Zealand that we milk a big chunk of the year. Yeah, and as Francois mentioned, you know, when you talk about those dryers that produce milk, we've got some dryers that produce about 35 tons of powder an hour. So it's a lot of milk that goes through some of those plants. Right, so what I want to talk to you a little bit about today is the role of applied food safety science in dynamic risk management. So you heard a lot about the regulations by Francois that sits behind it, but what I want to cover a little bit today is just the complexity of that food safety risk management. I'll bring it in the context of the risk analysis framework by Codex, and then want to spend time probably on 2 or 3 slides just about what we should be focusing on in terms of the science that underpins risk management, risk assessment, but also risk communication. All right, there's your food systems map. So for a company like VENTER, we export most of what we produce, and we export it to about 150 plus countries across the world. A lot of what we produce becomes ingredients in other people's products. So we really have to understand what the global food system looks like. And Gautier, seeing that's your birthday today, we'll ask some questions afterwards about this slide. So pay a bit of attention. The reason I put this up, and it's not my slide, it's from the Reddit Institute, which is just across the road from where we are in Palmerston North in New Zealand at Massey University. And they've developed this to explain global nutrition and what the food system in the world actually looks like and the variables that impacts the system. We use it at our end to understand where we need to deploy risk management from our perspective, especially from a food safety and quality focus. So it's quite complex. I'm not expecting you to read what's on the slide, so apologies for that. And then I was expecting Roy Kirby to be in the audience today, so I figured I'd get a picture that looks like Roy, what I think Roy looked like when he was a very young boy. Because if you look at this complex food system, you say, how the heck do I manage risk within this? This is sometimes the face you get from our risk managers when we show them this. It's a little bit more complex. And we've seen at companies like McKinsey come out and said, well, the way we do risk management in our companies are slowly changing. And I think COVID has been quite an accelerator of how we manage risk in our companies. And they came out and they said that dynamic and integrated risk management should include a better ability to detect risk. We have to be clear on what our company's appetites are for risk. So I think, as Francois said, if you decide that you've got a risk appetite and you're willing to look a different way when you get a positive either in your environment or in your product, then that'll come back and bite you. So you have to be clear on what your risk appetite is. You need to be clear, again, as Francois said, before you do your testing, what you're going to do when you get the results. So you have to be able to make those decisions, and you have to make them quickly. And for us, it means making them almost in real time. And then you look at the 5 bullets that Mackenzie highlighted there, and they said, well, you have to be clear on your aspirations for risk management. You have to reset them regularly and make sure they're aligned with your company values and what it is you want to achieve. You have to be agile in your risk management practices, so you have to be able to move quickly and change as you need to whenever you deal with different kinds of risks. You have to make sure that you harness the power of data and analytics, not necessarily the statistics that puts you to sleep, as Francois said, but more the cognitive analytics that sits in behind a lot of what we do these days. But then you also have to realize that you're dealing with people, and it's people that sits on your manufacturing floor. So you have to be very clear on the talent and how you develop tomorrow's talent as part of your risk management pool. And then your culture, your risk culture. So we hear a lot about food safety culture, but there's also a risk management culture, and you have to deal with both of them. And we have seen within our company that the more you go into the thought leadership culture, the better outcomes you achieve, rather than just an auditor-based culture. The good old risk analysis framework, it shouldn't be new to you. This is from Codex. It covers 3 areas: risk assessment, risk management, and risk communication. Now, I've purposely drawn it in a little bit of different way, where you see your risk assessment and your risk management overlaps a little bit. So many companies still deploy the good old church and state model, where your risk assessment sits very independent from your risk management within the company. That is a good idea, and we do that quite a bit in New Zealand as well, and even with our regulator, their risk assessment and their risk management function are completely independent. And the reason for that is that your risk assessment doesn't get clouded by any operational pressures. It needs to be independent, it needs to be clear on what the risks are that you're dealing with. But when you need to develop solutions, so once you understand what those risks are and you have to develop solutions, you need to get those two to overlap to some extent. Because otherwise your risk managers and your risk assessors lives in different worlds, and there's just a breakdown in communication. And when you've got that breakdown in communication, you get false positives and you get disastrous recalls like we've had in 2013 with a misidentified Clostridium botulinum. The main aim of risk analysis, and many may disagree with me, but in the end it's to reduce risk. Specifically for food manufacturers, it is to reduce risk. And there's a nice quote from MIT Sloan, which we have to keep in the back of our heads, because food companies have to understand when they deploy risk mitigation specific approaches, what will the impact be on your operations and what's the impact going to be on the cost. Because inevitably the cost of doing this will be transferred at some point in time to the consumer. And when you live in a world like we do today, where you see a lot of food inflation, food costs going up. There's a lot of pressure on food industries to try and keep the cost down as much as you can. So you have to bring it into balance with the risk management that you deploy. So a familiar world for many of us is in the risk assessment space. And many of us that go through universities would do all kinds of research, either fundamental research or applied research, or even on the commercial side of things within that risk assessment space. And should be pretty familiar. And we get asked the question a lot as an industry is, do you want to support our research? And that comes from governmental organizations, non-governmental organizations, universities, etc. And they'll come and say, please sponsor our research or work with us when we do research. And I always asked them the question and said, well, just keep in mind that there's not a big pool of funds that you can just deploy into risk assessment. And I think we do risk assessment reasonably well these days. But if I had $100, where do I need to spend that $100? Do I spend 70% of it on the fundamental sciences that underpins risk assessment, 20% on our applied sciences, and maybe 10% on making it actually commercial viable. So in other words, the research that comes out of the fundamental and then applied to deploy that into the business. I typically get a blank face and say, no, we're not sure where you should be spending your money. And then I say, all right, just hang on a little bit, because actually it looks like this. It's not just spending money into your risk assessment function when you do research. You actually have to consider what you're going to do within your whole framework. Where you're going to focus your research, because you can do the best risk assessment in the world, but if you can't communicate the outcome in your business and to a regulator, it's effectively dead in the water. You have to be able to communicate it. So hence, you need to do a little bit of research as well into that whole axis that works onto the risk communication. But likewise, your risk managers need to deploy that information and do something about it and deploy risk mitigation. So they need to be supported as well with some of the research you do. So if you go back to your $100 that you had, and this is actually where you should be investing your $100, and if you had to partition the percentage, where would you put your money now in terms of your research dollar? It is quite complex, so you'll see there that Colombo published a paper and said, you know, the days are long gone where you do these assessments with a paper and pencil. It's all scenario-based these days. If this happens, that'll happen. If that happens, that'll happen. And within this risk framework, this analysis framework, you have to consider all the elements. You can't just consider the assessment piece. And maybe just the last slide on the context. That's actually not the last piece of the story. You have to consider this within your whole food framework. You cannot consider this just on the shop floor. You have to think about the risk of if you produce an ingredient, you know, it goes through a whole supply chain to somewhere else in the world. Once it lands somewhere, someone's going to use that as an ingredient into their product. What do they do with their product? Who's the end consumer? What's that consumer going to do with it? It is pretty complex. There will be war somewhere in the world. How's war affecting it? You know, there may be energy shortages in the world. How's that going to affect it? There's greenhouse gas emissions. There's this whole drive for more sustainability. How's that going to affect it? So it becomes quite complex if you start to look at all those variables and how you deploy it. And if I go back to my question about my $100 of research money, where is it best to put that money? And I think if you've got that answer, you'll be in high demand, not just for industry, but also for universities and also for non-governmental organizations, because we all want to do research that's relevant. Yeah, and we want to make sure we spend our money in the right place. So we've had a go at it, looking at this multifaceted holistic risk management. So we recently published a paper just to give it a go. I invite you to go and read it. It may not be as bad as bedtime reading, but probably a bit close. There's a little bit of stats in there as well. That's enough about the context of the complexity of risk management. Yeah, but our world is changing. And you hear a lot about stuff like Industry 4.0. Can I just see by raise of hands who's familiar with Industry 4.0? Just see how much time I spend on it. All right, 5 people, so I may have to, maybe 6. So maybe I'll spend a little bit more time on it then. So this is a construct, I think, that came out from engineers, and just the way it's been presented. It's been presented by engineers, and we've seen this in our own industry in New Zealand as well. And again, COVID was accelerated this whole thinking quite a bit, especially for us in New Zealand, where we were locked down from the world for a reasonable amount of time. So it's quite nice to be able to travel again and travel to Europe specifically. Industry 4.0 is all about connecting. It's connecting your plants. And if you look at our manufacturing plants, and we've got several in New Zealand and other places in the world, it's all about data, and it's using your data to achieve some outcomes. And we're seeing that plants are way more connected than they used to be in the past. Last night at dinner, spoke with Marion and with Seamus. It's almost like every point you generate data now, you're starting to generate big data sets, like in big data sets. And it's the same with our manufacturing plants. In fact, some of those big powder dryers or protein dryers generate more data than some analytical instruments in a lab, because you have to monitor them. I mean, they run day and night, and you have to keep them optimized, and you have to make sure that your product that comes out safe at the other end. So you see big data being generated by manufacturing plants. you're seeing that those plants link with each other, and they link with control centers through the cloud. We see that we can operate those plants through the Internet of Things. We commercialized a lot of new food products during COVID when we were locked down and we couldn't let our scientists travel to the plants to go do the commercialization. So you saw the scientists sitting in meeting rooms operating big manufacturing plants, developing or manufacturing new products. So that Internet of Things is quite important. We're seeing a lot more system integration in terms of your blockchains when it comes to food traceability. Back in 2013, when we had our big global recall, we realized that our systems weren't talking to each other. So albeit that we run on one global system, it was different versions. And when you try to link those versions with each other, as you go through your supply chain, you had to do that manually. And it took weeks to get all the traceability done. We've invested heaps of money into that. And now what took us in 2013 took us weeks. Because we've got system integration now, you do that within seconds. So within seconds, you can work out exactly if milk came into your plant and it's split up into the protein and the fat and the sugar. You can trace exactly where it's gone. You can trace exactly into which container it's gone, which country it's gone to, who took it over, and which other part of the blockchain it linked into. So your systems are getting much more integrated. And then the last one is automation. So this is not just automation in our plants, which we've got as well, but it's also automation in your laboratories. It's more automation in your R&D process, and all of them have to talk to each other, and all of them have to stay connected. So all of this is taking that digital information and that data as part of your Industry 4.0 and saying this is what the manufacturing world looks like today and will likely increase to see tomorrow. So the question I've got is, what does food safety mean in this space, and how do you operate food safety in this space? What can we learn from that Industry 4.0 approach? And there's a nice quote by Thomas Davenport, who said that every company has got big data in its future. If you're a food company, you definitely will have big data in your future. And every company will eventually be in the data business. And if you're not experiencing that today, you definitely will experience that soon, because that's a reality. And it is a challenge. And again, we had that conversation last night at dinner. At our Research and Development Center, we've got about 350 people in the center in Palmerston North. They're from 42 different nationalities, so they come from all over the world. And if you add the years of experience, we've got just under that one roof more than 5,000 years of experience, which means you've got people there that's been there for 50 years and probably may have seen almost papers like the one, Francois, you showed there. Maybe not that one, but similar papers which are not even available in databases today. I mean, it's quite difficult to expect those guys to actually embrace this whole new digital world. They still have the paper lab notebook, and they still go into the lab, and when they do the experiments, they'll still note stuff down on paper. And that's why I put this little joke in, because cloud computing and cloud storage for them means different things than for the younger generation that comes in. But if you then say within this context of Industry 4.0, what does it mean for science? I tried to word it like this, and I'll give you an example after this. For fundamental sciences, we said, well, when we do research in the fundamental space, we'll answer the questions of what is happening and why. And this is not just for food safety and quality, it's also for our product development space. Because in the end, when you do your product development, your new product or new process development, you innovate safety in from that stage. You don't wait for your product to be finished with the development and then think you're going to deploy food safety onto that product or process. So you answer the questions of what and why. When you look at applied sciences, you say, well, how do I use this information which I've generated through the fundamental sciences and then go ahead and predict what's going to happen? And then the last one there, if you look at commercial relevance, it is how can I then use these predictions to control what's going to happen, either through my R&D process or through my manufacturing process. And I thought the best way to do this is to go back to the risk analysis slide and just show you a little bit of one of the things we've done in food safety and quality, which we call our virtual microbiologist. And again, COVID required us to accelerate this heavily because you know that microbiologists, and I agree with Francois a little bit there, that they, unlike chemists, they are quite valuable. Hey, is that it? I get in trouble because I've got many chemists in my team. But as a microbiologist, you know, you have to be present when you do your hazard reviews, when you've got challenges in your plant, when you work out the sampling plans, etc. So what we decided to do is, can we build a virtual microbiologist? So can we build a tool that from a commercial perspective will be fit for purpose, and it'll have to be digital because we wanted people to be able to carry it on their phone. It needs to be a fit for purpose digital interactive tool that you can use to help you reduce risk, but it needs to be within our existing processes, manufacturing processes, and the idea would be that you don't increase the cost of goods sold. So apologies for the acronym there. COGS. You don't want it to be too expensive when you deploy it. So we decided if we had to put this into our risk analysis framework, what kind of questions will you ask where? So I'll quickly go through this to just give you an idea. So if you look at the risk assessment bubble there on the bottom left-hand side, and apologies, it's quite small. If you look at the fundamental science piece, the question we wanted to answer there was, what happens in different products and in different processes and why? So it's the what and the why question. And then, again, as I discussed with Shay yesterday, it's not just about how a single organism will behave in a product, because that's not reality. It doesn't work like that. It is about all the microbes and how they actually behave in your plant. They don't exist in pure culture. It's a community of organisms. There's heaps of them. So just looking at one and just studying one in a test tube in the lab definitely ain't going to answer your question. So it needs to be about the total population. If you then move into the applied side in terms of the risk management axis, you'll say, predict how microbes will grow and how they will die. And that prediction is never done because microbes evolve and they change. You get new ones coming, you get some of them leave your plants. So that needs to be a smart system and it needs to be adaptive, and you continuously will generate data in this space. If you then look at the axis that goes to the communication side from risk assessment, we had to teach our scientists how, and get them to really understand what is the concepts, the scientific concepts that they will have to communicate and why and to whom. Yeah. So we started off probably 3 years ago. Some of our scientists still generated risk assessments that were 30 pages long. And you ask the question, who the heck in the world's going to read this? And what are they going to do with it? They'll probably file it straight away when it comes in. They'll look at the executive summary, and that'll be it. And they'll file it. So we had to teach our scientists how to use new tools like infographics, interactive infographics, our Shiny apps, all kinds of new ways of communicating exactly that risk which they've identified as part of their risk assessment. And they had to learn social science. We had to teach them you need to be smart in social science because the people you're going to communicate to aren't scientists. Yep. There'll be engineers, there'll be people on the floor, there'll be risk managers with commerce backgrounds, etc. So on that axis, they had to work out what science concepts will have to be communicated and why. And then we had to teach them to work out how to predict the impact. Not just the impact on the person that receives it, but also the impact on the operations. So if you say this, what will happen in the plant? If you say this, what would happen to risk managers? How will they see it? How will that impact policy? How would that impact strategy? On our risk communication side, the entities that look after that, we had to work on what communication and support will result in what required outcome and what. So they also had to understand if we communicate in a specific way, what will the impact be to the plant? Because we typically assume a lot of things. We typically assume people in the plants will know automatically what to do when you told them you found a salmonella somewhere. And that's not the case. Yeah, because not all salmonellas are equal and not all places where you find them are equal. Yeah, you need to be able to know exactly what to do. I'll go into the risk management space. For the risk managers, for instance, they always have two big questions. One of the fundamental sciences questions, and it may be that risk managers in different industries have different questions, but that's definitely the case for us, is what impacts do microbes have in the global food system? So not just in our plants, but what is the impact on that total chain, that whole system? So, and why? So they want to know where do they need to increase their focus or decrease their focus, and what do they need to do at specific places to reduce risk? And if they reduce risk in one part of that whole food system, what's the impact going to be in other parts of that whole food system? And then I think the applied science piece in the risk management was they wanted to know whether we can predict microbe-related risk throughout the global food system, not just in the plant. It's about the whole system, which makes it quite complex. Right. Last slide. So there's a saying by Steve Jobs, and I know there's a little bit of a debate whether he actually said it, and he's obviously not around anymore to say that he did or not. But it's a very valid statement, whether this is from Steve Jobs or from someone else, because that's the whole thing I tried to communicate in the beginning of the presentation. You cannot do everything, and you have to learn how to focus your R&D and your science. And people think that focus means saying yes to the things you've got to focus on, but that's actually not right. Hey, that's not what it means. Because it means saying no to hundreds of other really, really good ideas. And you have to pick carefully. You have to understand the consequence of your decision when you prioritize your research. And I thought what I'd show you is just some of the things that's in our innovation pipeline as far as food safety and quality go. And this is where we teach our scientists to show some concept leadership. So we do heaps of concept testing. Just in last year alone, we did about 60 new concept tests. Just to see how the risk managers would respond, how risk communicators would respond. So the virtual microbiologist is one, which I've shared with you. Many of you will be already working on shelf life, or maybe you've already got it, shelf life and quality prediction. Like with you here in Europe, reduction of food waste is high on the agenda. But also from a commercial perspective, if you're in a business of making dry powders with a shelf life of 2 years, the regulators require you to do 2.5 years or 3 years or sometimes even 4 years worth of shelf life studies before you can launch your product. That's a lot of time and it takes a lot of money, especially if you've got patents on what you're doing, because you lose a lot of time on your patent protection. So getting more accurate predictive models that you can share with the regulators and share with your customers to allow you to release some of that product a little bit earlier makes sense. There's, of course, risk prediction. Not just risk prediction in terms of your plant, as I said, but risk prediction across your whole food system. Making the invisible visible. That's a term which our global FSQ head came up with after he saw that what we've done in some of our plants. And he said, this is awesome what your risk assessors are doing now, because they're not just telling me I've got salmonella there and this there, they're actually making it visual. And he said it's the first time a risk manager can actually see what they have to manage. So that's become a little bit of a mantra for us in making the invisible visible. And it's not just for microbial contaminants, it's also for chemical contaminants. Predicting risk mitigation efficiency or efficacy to add to that decision making is pretty straightforward. When it comes to chemical contaminant concentrations, predicting where they go. Because it's quite easy to say, right, in a farm someone didn't rinse out their sanitizer appropriately. But, from the farm vat, it'll go into a tanker with 20,000 liters of milk. It'll go into silos in the plants with millions of liters of milk. And then that divides up into multiple streams. Some of them come together again. Some don't. Becomes different products. Goes into different containers. Goes into different parts of the world. So understanding exactly where those contaminants concentrate, where they dilute, all of that becomes really important from a chemical contaminants perspective. Digital twins. You would have heard that a lot when we commission your plants now, and even in the R&D space, you make sure that there's a digital twin, because that's effectively our flight simulator. It's much easier to do that process optimization digitally than having to go and do that in plant with real product, because that's quite expensive. It also helps you with the change control training, etc. We also deployed in food safety quality culture maturity assessment. Can you predict that? Can you predict events and recalls, emerging risk? Can you predict risk communication and the impact of your risk communication? And then lastly, can you predict the efficacy of your change management in your system? Right. So a lot in there. And there's much more, but it's about prioritization, as I said. You can't do everything all the time.